Hello again. For this presentation, I'm going to run through the analysis for the second option for the first part of your coursework for quantitative, the quantitative coursework. So the second choice you have, the first choice is the bereavement database. The second option you have for the first part of your coursework is the Shyness database. And this again is a published paper by Crozier and Hostetler that looked at the influence of shyness on children's test performance. Again, what I've done is simplified the database to include only the variables that you require in order to address the research questions. So here we have the three research questions. Is there a main effect of gender on children's vocabulary ability? Is there a main effect of shyness on children's vocabulary ability? And is there a gender by shyness interaction? If you look on Moodle, you will see that the original Crozier paper is on there, so that will give you enough information for your introduction and your method section. I'm specifically covering the results and how to run the analysis in this particular presentation. Again, one-to-one support will be available as we progress through the module. So basically, what I'm going to look at is how to run the analysis, starting with exploring the data for normality to make sure our data meet the assumptions of normality. So first let's have a look at the variables. So we have two factors. It's a 2x2 ANOVA. Our factor of shy status is children are divided on their shy status. So 0 represents not shy, 1 represents shy. If we look at the gender variable, here we can see 1 represents male, 2 represents female, and our dependent variable is children's scores on the Crichton vocabulary scale. Again, details of that particular measure are available in the paper that I've put on Moodle. Also, you can do your own research for your introduction if you wish. So what we're going to do first is run through the analysis. So first we're going to explore the data, so analyse, descriptive statistics, explore, and we're going to divide our output by our factors. So we start by placing our dependent variable into the dependent list, shy status into the factor list, and sex of the child into the factor list as well. As before, we will create a histogram and we will select normality plots with tests so that we get the Kolmogorov-Smirnov output. Click continue and then OK, and then we look and wait for our SPSS output. Just taking a sip of water there. Okay, so let's see what we find. So if we look at our output, scroll up to the very top, we can see our dependent variable is our Crichton vocabulary scale, and we can see the group differences here. There is a slight group difference there, but we can point this out when we in our method section under participants. We can point out the group differences. Again, it's something that we might want to pick up on in our discussion section, where we report the findings and state that group differences can be problematic. However, we are going to proceed with the ANOVA. Going to skip past that table and come to our Kolmogorov-Smirnov output. Here we can see our values are both greater than 0.05, so it's looking good. It looks like our data are normally distributed. Here we can see the non-shy children on the Crichton Vocabulary Scale distribution looks pretty normal. If we look at the shy children, their distribution on the vocabulary scores, again it looks like there's a little bit of positive skew there, but our Kolmogorov-Smirnov test is telling us it's normal. And again, if we did the frequencies, the analyse descriptive statistics frequencies, and fitted a normal curve to that, it might look pretty normal. Something to do with this person up here who scored 40. But let's have a look at our QQ plots. Here we can see this is our expected distribution if it's normal, and here we can see our observed, and the dots are adhering quite close to the line. If we look at the shy children, here we can see that what potentially is an outlier, that score of 40, kind of deviating from the expected normal distribution. But let's move down to our box plots and see if we do have an outlier. Yes, we do. Here's participant number 95, who is in the shy status group, who scores 40 on the Crichton Vocabulary Scale. Now we've a choice here. We can either leave it where it is, we can remove it, or we can replace participant 95's value with the mean value for that particular group. But for the purpose of this demonstration, I'm going to leave it where it is. The choice is yours. You can remove it, or you can replace it with the mean. Whatever you do, it's fine as long as you report it. Okay, so we can kind of conclude that, you know, the shy children, their distributions are normal. So let's look at the gender, the sex of the child now. Again, there's a little group difference there which we might want to acknowledge. If we look at the Kolmogorov-Smirnov test, we can see again we have a non-significant, a p-value greater than 0.05. So again, it's looking like we have a normal distribution. Let's look at the frequency histogram for males, for boys. Here we can see we have something that again resembles normal. If we look for girls, for female, again we can see we have something that resembles a normal distribution. So let's look at the QQ plots. Here we can see our potential outlier here for males, but most of the other observed scores seem to be adhering quite closely to the expected. If we look at girls, for females we can see again the observed values seem to adhere quite closely to the line. So let's move on to our box plots. So it doesn't look like we have any outliers in this particular for this particular factor for both of the levels. So I think our conclusion would be that the data are normally distributed. I will leave it to you to decide whether you include the outlier or you exclude it, or you replace the outlier with the mean, the previous outlier that we saw. But here clearly we don't have any outliers. So the conclusion would be, with due acknowledgement of what we did with the outlier, whether we left it where it was, etc., is that our data meet the assumptions of normality. So we will proceed with our 2x2 analysis of variance. So we'll start the main analysis now by going into Analyse, General Linear Model, Univariate. Our dependent variable is children's scores on the Crichton Vocabulary Scale. Our fixed factors, or our independent variables, are the shy status of the child and the sex of the child, the gender of the child. So again, we need to go down this menu here. So if we click on plots, we can move our variables across to the horizontal axis and separate lines. We don't have more than 2 levels of factor, so it doesn't again really matter which box these move into, whether it's horizontal axis or separate lines. Add them to the box, click continue. We don't need to carry out post hoc tests because we only have 2 levels of each factor, so we can go straight to our options button. And remember, the estimated marginal means facility is actually on a separate menu on the newer version of SPSS, but in my older version it's included under the options. So we'll move the variables across: overall, shy status, sex, and the shy status by sex interaction. Going to click compare main effects, and descriptive statistics, estimates of effect size, and homogeneity tests. Continue, and we're good to go, so we're okay. And then again we wait for the output. Our between subjects factors table tells us how our factors and levels are coded, how many participants in each of our groups. We don't need to include that table in our output. We don't even need to comment on it. It's just so that we can check how we have our variables coded. The descriptive statistics table is really important, and you are expected to include a descriptive statistics table in the main body of your results section. We can comment on the means, but we can't discuss significance yet because we haven't performed our inferential test, our ANOVA. So we can look at the total for non-shy is 30.73, and for shy children 12.83. These are the mean scores on the Crichton vocabulary scale, and we can comment on those, but we mustn't discuss significance. The next thing to look at is the Levene's test for homogeneity of variances. Okay, now here we can see that our data do violate that assumption. However, because of the purposes of this exercise of doing an ANOVA, we are going to proceed with the ANOVA. So do comment on the fact that Levene's test was significant, therefore the homogeneity of variance assumption was violated. However, it was decided that the ANOVA would be performed. So the next thing we look at is our tests of between subjects effects. So what do we have? Here is where we address our 3 research questions. Is there a main effect of shyness? And we look at the shy status row, and here we can see that we have a significant main effect of shy status. So we can report F, degrees of freedom, 1,98 equals 78.68, P is less than 0.05, and our partial letter squared is 0.45, which is just below moderate effect really, but what it's telling us that the main effect of shy status is explaining 45% of the variance in our dependent variable. Our second research question was, is there a main effect of gender? Yes, there is. It's significant. Again, we report F, open bracket, degrees of freedom, 1,98, close bracket, equals 124.47, P less than 0.05. And here we have a slightly better effect, actually, a stronger effect. In fact, it is a moderate effect, and the effect of gender is explaining 56% of the variance in our dependent variable. The partial letter squared is telling us that. And then finally, our third research question was, is there an interaction between shyness and shy status and gender or sex? Yes, we do have a significant interaction. Again, we report F, degrees of freedom, 1,98 equals 17.26. P is less than 0.05, and it's explaining 15% of the variance in our dependent variable. So it's a very small effect, but nonetheless it's significant. So once we've reported our the answers to our three research questions, we can actually go back to the means and look at the differences between the means and report the direction of means. Okay, the direction of the significance. But because we have a significant interaction, the next thing we look at is our profile plots. Now here we can see what appears to be the source of the interaction, and that is non-shy children. So children who are not shy, or females who are not shy, score significantly higher on the Crichton vocabulary scale than males do. Okay, so again, it's these two variables working together to create some kind of effect. So for non-shy males, the Crichton vocabulary mean is significantly lower than non-shy females, or the other way around. Non-shy females score significantly higher on Crichton vocabulary scale than males do. So again, what we could do at this stage is perform our simple main effect analysis, our independent t-test. We can select the non-shy children only, and then run a t-test between males and females on the Crichton vocabulary scale and see if that difference is significant. We're comparing these two means exclusively. And then we can flip it around and we can compare the same for shy children. So we can select shy children and compare males and females on Crichton vocabulary scale, and we can report those differences. So that concludes the analysis for the shyness database.